Okay, perfect. So let's get started. So here is a slide. I'm Antonio Jiménez, and today I'm going to talk about OpenTelemetry. What is going to be my goal after the meeting? So all of you understand about that open source technology, and think about it if you can integrate in your companies, if you can use it in your daily work. This is my goal for today. Before starting, I would like to talk a little bit about myself. So let's get started with where I studied. I studied in computer science in Granada, in the university. Many of you know, I guess. And my last year was in Sweden, in Linköping. It was a city close to Stockholm. And here I was lucky because I directly jumped to work on Ericsson here in Sweden. I was mainly doing backend stuff in Python, but it wasn't as nice as you can imagine. Every day was raining and snowing, so it wasn't as perfect. And then I came back to Spain. I started working in Granada in RTI. In that company, we were building a middleware to communicate data. Then I moved to the Warsaw, one of the sponsors today in the meeting, in the conference. And finally, where I am today is on Cisco Thousand Eyes. Here, what we do is like we monitor the network. And what I do specifically, we are in the streaming team, and we stream Thousand Eyes data to our customer. Between my hobbies, I have sport, traveling, and friends. Cool. Let's go to the meat of the presentation. Today, we're going to talk about OpenTelemetry, an introduction. Later, we're going to jump into Thousand Eyes. We are going to talk about the architecture of using OpenTelemetry in our company, in our product, the challenges that we have faced during implementing that one, and of course, a demo. Everyone loves a demo here. So let's go there. What is OpenTelemetry is? The way how we see it is an open source project based on observability. So it manages telemetry data. It is a collection of tools, APIs, and SDKs. So it is not just an API, so it is more things. OpenTelemetry allows you to instrument your code. So if you have heard about logs, traces, and many of those pillars, OpenTelemetry allows you to instrument them. Sorry, to instrument your application and generate those signals. Plus also allow you to collect the data and export to any observability backend that you decide. Here you can see the three pillars. We have like traces, logs, and metrics. This is not going to be a talk about the signals. This is going to be more a talk how to use OpenTelemetry. They are also working in another signal, which is profiling. So get ready for the next one. This is a picture that I really like, talking about how OpenTelemetry works. So we have application built on Java, Python, AWS, whatever language that you have out there, Apache, Node, any there. And then OpenTelemetry is going to instrument your code automatically or manually, so you can do it in both ways. And then it's going to generate those signals that I mentioned. It could be like traces, metrics, and logs. And also, they are going to collect and export to any observability backend. So as you can see there, we have plenty of observability backend like Splunk, Honeycomb, Datadog. We have someone here today, and so on. So now you know the meat of the presentation, OpenTelemetry. But let's jump to one of the main tools, which is the collector. So a question that they have, how many of you have heard about the OTL collector before? OK, like a few hands. I like to see that. So the architecture of our product is based on the collector. So it's super important for you to understand it. And if you have questions, stop me here. The collector is quite flexible. It allows you to receive data. It's a kind of adapter between two source and destination. So it allows you to receive data. You can receive it using different formats like Prometheus, Jaeger, OTL, which is the OpenTelemetry format, reading from a database, reading from a WebSocket, anything. It is totally configurable. You can build your own component to read that data as you want. And the data is going to be read on the receiver in parallel. So if you have 3 receivers, they are going to receive the data in parallel. Now you have the data. Now let's jump to the next one, which is processor. In the processor, you are going to process that data, and this is going to be in sequential. So you're going to have several components to process that one. And here you can have things like filtering. A filtering component will allow you to filter out data that you don't need. Like imagine that you want data to be in real time, so you drop the data that is all. Or you want to drop data that contain information that might be risky to send to other people or whatever. So this is the place where you filter out. Or you can also add extra attributes. So maybe your data point is missing some of the fields. You can add it at that time. Or also you can batch it. So for performance reasons, you batch the data point together. And then in the next phase, which is the exporter, when you export it is more efficient. For the exporter, it's the same logic that the receiver. They are going to be in parallel, so the data point is going to be sent as many exporters as you have to many observability backend. And you can do it in different formats like OTLP, Jagger, Prometheus, and many more. And you can also build your own one and send data to a database or into a file or in the terminal. You decide that one, okay? So now you understand the main three parts of the collector, but we also have the concept of extensions. Those are cross components for the whole pipeline, and they help you to manage the collector. They could be like the health check, the pprof to know the memory, cpages, and many more. I will explain that in more detail now. So I hope now you understand a little bit better the collector and how we will use it. Now let's jump into Thousand Eyes. So as I said before, what we do is we monitor the network. That might sound a little bit general, but it is true. So we detect when there is an outage at any place in the world. So as you can see here, we have Monday.com that is suffering an outage on the States, and Microsoft is also suffering an outage on India. So we detect when there is a page is dropped, and we detect the problem and the issue. And this is the data that we are generating. We run those tests all around the world. That is quite important because we want to know maybe Microsoft is working in UK, but not in India. And also, we run the test inside of the customer infrastructure, but also outside. So we know when there is a problem inside the customer infrastructure, but also outside. That is quite important. Let's now see the Thousand Eyes network test. This is the main one that we are going to talk today. And that allows you to run periodically those latency and page load and loss and availability tests to the page to know if this is suffering an outage or not. Here, just to give you an estimation, we are working with around 30K of data point per second, which might not sound too much, but if you want to process and detect problem, it is too much. The data as today is only accessible through APIs and dashboard. Now you know about OpenTelemetry and you know about Thousand Eyes, so let's go to the motivation, why we have adopted OpenTelemetry. Let's jump into a prior art. It is quite important because we need to know where we were before. Before, the Thousand Eyes data was only accessible through a dashboard and through an API. The API was, of course, a REST API, which means that it is a pool-based. It means that if a customer wants to access that data, they have to create their own integration, and they have to query that API periodically, get the data and transfer into their format. The data that we were providing was in JSON. As you can see in that example, we were doing a query, and that was the output. And here you have everything together, like latency, loss, average. So all the data was flat on the same output. Perfect. So now let's move to our motivations. OpenTelemetry is a vendor agnostic. I didn't mention before because I wanted to mention here, which means that we are not the only one using it. We are not the only one implementing. There are people from Datadog. There's people from Splunk, New Relic, and many other companies, Grafana, doing work on that. So there is not just one company behind. There is plenty of companies because it is an open source project. And also have a specification, which if you rely on the specification, means that your product is going to work. Also, we are not the only one working with OpenTelemetry. It is widely adapted industrially, which means that there are plenty of companies using it, like Grafana, Splunk, Datadog, and many more, which means that there are plenty of integrations. So if you want to send your data in OpenTelemetry, you're going to be able to visualize in many places. So let's now go to the goal. We want to facilitate our integration with our customer. We want to use a push API, which means when the data is there, we send it. We don't want the customer to query that data periodically for no sense. Plus, we need to be in real time. So when there is an outage, we are going to send it to the customer, and the customer is going to be able to act. They don't have to wait until they are lucky to get the pull of calling the API and then act. Now you know motivation and goal. Before jumping to the architecture, I would like to explain you a little bit the data model. The data model, we are going to talk about the test data. As I mentioned before, it could be like on dashboards or in API. Perfect. The next data model is tag. The way how we use tag is to group a list of assets together. In that case, we are grouping test. Network test, we are grouping together under a tag. The tag is identified by a key value. And the main one, and more important for us, is integration. What we do here, we say the format that we want for our integration, so it is going to be OpenTelemetry type for the format. Specifying the tag match, we are going to say to which test we want to associate with. So in mind, those two tests that we said before are associated with that tag and are generating data. We are going to send that data to the URL. So we are going to send that data to that string endpoint URL, the target. Plus, we are going to use an endpoint type, which means the protocol that we are going to send the data. We could have HTTP or gRPC. And of course, if we want to send the data to one, for example, in that case is Grafana, if you want to send it there, you also need an authentication headers to do that. So this is our integration, the main one for today's work. Now, we are going to see how they are associated. So we have the test associated with the tag, which is associated with the integration. That way, we can associate 100,000 of tests with a single integration. You know about Thousand Eyes and OpenTelemetry. You know our data model. Let's jump now into the architecture. Our Thousand Eyes data, we are receiving the data from Kafka, so we have the concept of agent. The agent is the one running the test and generating that data. The agent is the one sending that data through Kafka, and we are subscribing to that topic. And we receive the data in one of the collectors that I mentioned before, which is the metric collector. In that place, we are receiving, processing, and exporting to the integrations collector. Here, what we are doing is receiving, processing, and exporting to any observability backend that the customer have configured. We also have the concept of metadata service, which is going to help us to enrich our data points. That diagram might seem a little bit like a high level. Let's zoom in and see now a better picture. Here we are going to have all the components of the different collector. The reason why we have also two collectors is for two reasons. First one is data domain logic. So in the metrics collector, what we are doing is we are converting our Thousand Eyes metrics into OpenTelemetry metrics, and we are processing them. So this is for the domain of the metrics. And the integration collector, what we are doing here is like we get the data point, and we decide to which observability backend we send. Okay, that go to Datadog, that go to Grafana, that go to Splunk. As you can see, the model are different, but not only that, the scale is different because that collector is going to scale based on how much data you receive from Kafka. The Kafka is the one deciding how you scale. If you have more tests, we are going to scale more. And that one is going to scale depending on how many integrations our customer have created. If a customer creates thousands of million of integration, that means that we are going to need to scale to process all of them. Let's zoom in again and see component by component. As we mentioned, the test data is going to be received in Kafka by the Kafka receiver. And now we are going to move to the first processor, which is going to be the filtering. Here is quite important. Why? Here we are receiving the data of all our tests from Thousand Eyes, but not all of them we want to export to our observability backend. So here is where we are going to filter out the data that we don't want to send to any observability backend. Plus, we said that we are real time, right? So we want to drop the data that is older than 1 minute. So because we want only to work with the data that is real time. In mind that you have lag in your Kafka, we want to drop that data. Perfect. So now we go to the attribute processor. Here, the data that we receive from Kafka is incomplete. So don't have all the data that you needed. It is missing. We only have like agent name. We need also the agent location, the test type, test name. All this data is going to be enriched on the attribute processor. And now we go to the batching. As I said before, we are going to batch data point together to be more efficient. And the next one is also exporting that data using the OTLP exporter from OpenTelemetry using a gRPC protocol. Now you understand the metric collector. Let's jump into the integration collector. Here is a little bit simple. Here we receive the data using an OTLP receiver with the gRPC protocol. And then we move it to the integration processor. That is quite important. Here, if one data point is going to be sent to two observability backend, we need to replicate that data. We need to make it twice. So one data point is going to go to one exporter, and the other one is going to go to the other exporter. And that is going to be decided on the OTLP routing. This is the one deciding, OK, that data point have that integration ID, and that go to Grafana. That one go to Splunk, and so on. This is the place where we are routing our data point to the specific observability backends. Now we see back the high picture of our diagram, and I would like to talk about the extension. I didn't talk before because they are shared between the collector. Here we have several extensions. The first one is health check. It is quite important because when you're working with Kubernetes, you need to know when a pod is ready, is initialized and working. So we are going to use the health check to know if our collector is ready. So the Kafka is already receiving data, the storage is already populating the cache, and many more things. The storage, this is one of the main extensions. I will explain more detail later, but here you want to understand, like, we are going to get data from the metadata service, and we are going to save it on the storage extension, and that one is going to be used all around the rest of the component to enrich and filter out. Plus, we have also the event bus. So it is a PAP subsystem to send event and receive event in another component. Just to give you an example, when we are dropping a data point, we send an event, and the metrics component is going to receive that event and is going to increment a metric. We also have the Sentry component, which is catching all the errors and all the panic in Go, and is sending them to a Sentry framework. And the last one is the metrics extension. So here we also observe our observability application. It means that we are generating logs, traces, and metrics. And for the metrics, you can imagine things like data read from Kafka, data that have been dropped, data that have been sent to a specific observability backend, how much time do you need for the whole pipeline, and many more things. Cool. Now you know all the extension, all the diagram, so let's jump into the next section, the challenges that we have faced during the process. Between the challenges, I want to talk about data transformation. We need to convert from thousandized proprietary format into an OpenTelemetry format, which means that we need to transform that data. We also have dynamic metadata. Imagine that you create an integration. You want that integration to start sending data automatically. You don't want to wait minutes or hours, right? So we need to be dynamically getting the data, getting the test, the tag, the integration, and adapt our collectors for that. Multi-tenancy. We need to make sure that the data from one customer is only sent to that customer. Why it is important? Because we are not going to send outage data from Microsoft to Monday.com. So this is quite important. Health and liveliness. As I said before, we need to make sure that we know when our collector is ready to mention, we are going to have an endpoint to say liveliness check that say if the health and the liveliness is ready. Sentry, as I mentioned before, we need to send the data, the errors and the panic to Sentry. Scalability, we need to scale not only based on memory and CPU, as we are used to see, but also based on number of integration and number of data that is coming from Kafka. And the last but not least, which is quite important, is we need to observe our own application. For the sake of timing today, I only want to focus on the first one. Data transformation. We are going to need to transform our thousandized data into OpenTelemetry. Thousandized data have a proprietary format. Each test type is implemented by a different team inside of thousandized, which means that they are using their own protocol, their own format, their own way of structuring the data, so everyone is different. The data can be received in JSON format or in gRPC, protobuffer, of course, and the data is going to be flat. So in one Kafka data point, you're going to have like loss, page load, latency, all of those. And we need to separate them because in OpenTelemetry logic, only a metric is contemplated in a single data point as a metric. And each thousandized test type is going to have different attribute and metric. We'll jump into them. How are we going to solve that? We are going to use our Kafka we are going to use the Kafka from OpenTelemetry, the Kafka receiver, but we are going to extend it. We are going to use a different unmarshaller for each test type. That is going to be giving us the flexibility to parse that data differently for each topic. So let's see an example. Let's see how that is going to work. As I mentioned, we have network test data, but they are going to be different ones. So one of them is going to be ping. The ping data is going to be sent through Kafka, and it's going to be receiving the Kafka receiver through which we are going to have a ping unmarshaller. That is going to convert that data, that is just a single data point, into several OpenTelemetry metrics using the ping unmarshaller. But not only there, we are also going to have another Kafka, which is going to be HTTP, which is going to transform the data into OpenTelemetry using the HTTP unmarshaller. Those two, as you can see there, are gRPC. But the next one is endpoint test. That one is different. Here, it is in JSON, and what they are doing is different because they have all the test type like ping, HTTP, and many more on the same JSON. So they send the whole JSON through Kafka. Then we need not only to unmarshal the different test type, but also split that JSON into different ones. That's why we need now 2 data sources. But the logic is the same. We unmarshal JSON, and then we convert it into OpenTelemetry. Cool. Now we have the data. So let's see how our data point is going to look like. We are going to have like name, the description. We are going to have gauge for the value. We can have like counters, histogram, summaries, and many other ones. But in our case, it's a gauge because it can go up and down. We are going to have also the time units when we were converting that data. We are going to have a bunch of attributes for our scenario. Here we can find things like test ID, agent ID, or permalink, or integration ID, and many more. So this is how a JSON representation of our data point looks like. Let's move to the next challenge, which is dynamic metadata. Here we have 3 problems. First one is, when a customer creates an integration, we need to adapt quickly to start sending data for that integration, which means that we need to start sending the data. Next one is, our data points that are coming from Kafka might be incomplete. So we need to enrich that data point with data from the metadata service. And the last but not less important is, we need to be efficient, which means that if you're receiving data from Kafka, a test that is not going to be sent to any observability backend, you need to drop it. Why do you want? You're not going to use it. The way how we are going to solve that is by having a catch. That catch is going to be refreshed periodically, calling the metadata service, the service that I mentioned before in the diagram, and we are going to do it based in a key value format. That key value format is going to have, for example, test ID and the whole object of the test, or agent ID and the whole object of the agent, for the same for integration, the same for tag. That data is going to be a storage, so all the components of our collector can access to it and make it use. But as before, it is better to see with an example. We are going to have from ThousandEyes 2 data points received. One is with test ID 1234, and another one is 4321. Cool. We are going to, in the receiver, we are going to transform them into OpenTelemetry data point. And now we are going to see the test ID 1234 is associated with 2 integrations, which means that we are going to export to an observability backend. So let's continue that data point to the next pipeline. But the other one, the 4321, is not associated with any integration. So why do we want to keep it? So let's drop it on the first stage. Let's drop it here. Now we move to the enricher. In the enricher, what we are doing is we have agent ID 60. And now we have also from the agent storage, we have the name and the location. So let's add those name and location as attribute of our data point. So we are enriching our data point. And we move to the next pipeline. So as you can see, we need to be dynamic, getting the data from metadata service to do that enrichment. The next challenge is going to be multi-tenancy. As I said before, we need to make sure that the data that we are generating in ThousandEyes is sent to the correct customer. And why it is important? Because, as I said before, this data can be run inside of the customer infrastructure. And that might lead into sending IPs or MAC or private IP to the customer that is not the correct one. The way how we identify a customer is by the target endpoint and the authentication headers. The way how we are going to solve this problem is by the concept of a tenant aware. So our integration, the tag, and the test, all of them are going to share the same account ID. So we make sure when we receive the data in Kafka and before exporting that we are using the same account. On that way, we always ensure that we always send to the right customer. For doing that, we are using OTL routing exporter. Here is where we decide that data point is going to that observability backend. The other data point is going to the other observability backend. Let's also see an example of how that is going to work. Remember the data point from before? It is already converted into OpenTelemetry format, and now we are going to go to the replication processor. Here, that data point is associated with two integrations, so let's replicate it and also add the integration ID as an attribute. Perfect, now we have two data points on OpenTelemetry format. And now we go to the integration storage and say, that data point with ABCD integration ID is going to be sent to the exporter one. So let's route to that one. And that one is going to be sending data to, let's say, Grafana. So we're going to have an exporter per integration. So each integration is going to have an exporter individual to send data to that Grafana, Splunk, or whatever. And for the other, the same. So we have BCDE, which is our integration ID, and we are going to send it to the exporter 3. The exporter, as I mentioned before, they can be using gRPC or HTTP protocol. By doing that, we ensure that we are sending the data to the correct destination. Now we have seen the challenges, and now it's time for seeing the demo. In the demo, we want to create a test. We are going to create actually two tests, a network one and an HTTP. We are also going to create a tag, associate the test to the tag, and then we are going to create an integration. That integration is going to go to Grafana. Then we are going to open Grafana, and we are going to visualize our data point being received then. So how the whole workflow that I explained today on the architecture, we are going to see how it works. Sorry if the size is not that big, but I'm going to explain. So we are creating here a HTTP server test, and now we are creating, now those tests are calling Google and checking if Google is up. And we are also going to have an integration network test. And now we are also going to create that tag. That tag is going to have that ID, perfect. And now we are going to, as I said, associate this tag to the two tests that we have created before. So I'm going to create here the associations. I take the tag ID. I take the test ID that I just created. Awesome. And now I take the other test ID that I just created before. So the test ID, going to the association, perfect. And now we are going to create the integration. Let's wait a second. Perfect, the integration. The integration is going to go to Grafana using the Grafana token, also using the tag match that we just created. And here is the integration that we created. Perfect. Now we are going to see, one second. OK, now we are going to see, mind that we were in the previous OpenTelemetry, before OpenTelemetry, how did it work? We are going to give me the result of those test types. So we are going to get the test name, the agent that is running that test, and we are going to get things like the response code. This is calling the API, OK? Not OpenTelemetry. We are going to have the receive time, the end time, total time, and many more things. Now for the other test, we are also going to get the result. Remember, this is the network test. Let's run it, perfect. And here we are going to have like test ID, test name, also the agent that is running, and more things like latency, jitter, and loss. So as I said before, thousandized data was only accessible through an API, as you have seen. And now it is also accessible through an observability backend like Grafana. Here in Grafana, those tests that you see there, they are from before. And now you will start seeing the new test. Correct, it is already there. So you are going to see, like for HTTP tests, we are going to have throughput, response time, and availability. And the new test is going to start appearing there, as you can see. So we are start receiving data from the integration that we just have created. We have also the network test, which is going to have like latency, loss, and jitter. With that, I want to explain like ThousandEyes tests can be sent now to any observability backend that you decide by those 3 steps: test, tag, and integration. And start visualizing easily in your observability backend like Grafana that you're familiar with. You can use any of the one that support OpenTelemetry. So as the topic was called what we have learned, let's do a recap. So about OpenTelemetry. The standard said the model, but in our opinion was quite limited. As I mentioned before, we also only have like name, description, gauge, the value, the timestamp, and a list of attributes. We were missing more things here. Also, creating a new component on the OpenTelemetry collector was quite challenging. For the one that put your hand up before, I don't know if you have created a component or you have just used it, but it was a little bit challenging at the beginning. If you are, go better, but if not, it's also more challenging even. But once you have it ready, it is super easy to work with the whole ecosystem. Why? Because the OTL collector is super flexible, so you just create components, you just create receiver, processor, and exporter, and make them work together. Also, there are plenty of components from OpenTelemetry as today, and the good thing is that they are extensible. Remember that I said there is a Kafka receiver built by OpenTelemetry, so you can add a marshaller there for your own topic, and that is quite useful. And the last but not least, in my opinion, is the most important. There is a huge community behind. So you can talk with them through Slack. There is a Slack channel. You can also talk by LinkedIn or in GitHub. You can create GitHub issues. You can even contribute yourself. We encourage you to do it. So you can. It is an open source project, and you can take a GitHub issue, find out a maintainer that might guide you and help you with the review and everything, and let's do it. We have also here in the room one people that work daily on the OTL collector. That is quite useful to see those people around. So as I said, OpenTelemetry have a huge community behind, so let's get used. Also, there is a lot of documentation out there. With that, I want to conclude the presentation. Here you have like the LinkedIn for the company. We have a few open positions also for ThousandEyes, and also my personal LinkedIn in case you want to send any question. So thank you so much, and it was a pleasure to talk about OpenTelemetry for all of you. Now, if you have any question, is the moment. Oh, cool. Las preguntas podemos hacerlas en español, inglés, como te sientas cómodo.
No worries, we can check it. Yeah, sorry. A concrete question about OpenTelemetry concretely would be a typical use case for logging data, no? If I have, for example, a Java application that I am tracing with OpenTelemetry, a concrete case of logs, for example, if I have a null pointer section or something like that, I mean, and I stack trace in multiple lines, that use case is covered by default in OpenTelemetry SDK, or I, as a developer, I have to do some custom method to treat in that concrete case. I mean, instead of receiving my observability backend multiple chunks of an stack trace of error to receiving it in a single one, I think that case is covered by Datadog and other providers. In the case of OpenTelemetry, should I, as a developer, I have to take care about it or not?
Okay, it's a really good question, to be honest. So OpenTelemetry provides you the logs, traces, and metrics, okay? Mm-hmm. You were talking about logs. If you only have logs in your picture, yes, this is a problem. But usually, everything goes together. So you have the concept of trace. Are you familiar with trace? Perfect. So with a trace, you're going to see the whole flow, the whole stack trace of your application. And then it is going to have a trace ID. With the trace ID, you're going to be able to correlate all those messages, because all those messages now are going to have an extra field called trace ID or span ID. And all of them are going to be able to share the same trace ID. So you're going to be able to say in Kibana or FluentD or any of the, or Elastic or whatever, any of the observability backend for logging, you're going to be see, okay, for that you find out your exception, and that exception is going to have a trace ID, and now you said, I want to serve by that trace ID, and you're going to see all the logs related with your problem. So all the stack trace is going to appear there. But also, I would also encourage you to not only look at logs. I mean, we have been taught to use logs for debugging problem, and it's useful. They work. But if you go one step beyond and use metrics and traces, your life is going to be way easier, because inside of the trace, you have a concept of calling event, and the event is nothing else than a log. So, and in the trace, you're going to be able also to see the exception. So I encourage you not only use that efficiency of correlating logs by trace ID, but also use trace by itself.
Okay, so if I got it right, in short words, basically in the observability backend, I should take care about that concrete case, right?
Absolutely. Not the observability backend. OpenTelemetry, when generate the logs, is going to add a trace ID as an attribute into the log.
Per chunk of the trace?
Correct. I mean, it is going to be there. So when you are looking in FluentD or in Kibana or whatever, you're going to see that trace ID. And now just search by that trace ID. And you're going to see all your logs or your stack or your trace.
Okay, perfect.
It's a way of correlating them.
Okay, perfect. Thank you so much.
We can talk later if you want for any problem like that.
Another question?
Any other question, guys? Thank you.
Yeah. Hi, thank you for the talk. I have a question regarding how many exporters usually should be the OpenTelemetry exporter when you configure for an API, should be configured one exporter for the full API or one per endpoint from the experience? I mean, I would like to know, because I usually use, for example, Elastic has APM, and then you configure and you have everything for free. But I never work on more specific configuration for OpenTelemetry. So I would like to know about your experience about exporter. How many exporter it is normally used? One per endpoint or one per API? That's all.
Okay. I think I got your question. Perfect. So the way how I see people doing is, in mind that you have 20 microservices. All those microservices are going to generate telemetry data, and they are going to be sent to a OTL collector. Okay, and then on that OTL collector, you might just receive and send it, or you can add extra processing. But the good thing is, like, that OTL collector is gonna remind that you have like Datadog and Elastic, both of them. So you're gonna need to have two exporters for them, but you don't have to put the exporter in your application. So you are gonna send your application telemetry data to a collector in the middle. It's super simple to manage, don't have that much work. And then that collector is going to have the exporter as you may need. Imagine that you tomorrow want to also try Grafana or Splunk, or you want to have for logging Grafana and for tracing Datadog, or as you prefer. So one collector per observability backend is the way to do it. Right. Thank you. Good question, to be honest.
Any question?
Any other question, guys? We can do en español, ¿eh? Podemos hacerla en español si alguno se siente como que no le apetece un poquito hablar en inglés. Por mí está estupendo también. ¿Se anima alguien en español por aquí? Bueno, pues.
Okay. We have food and drinks now in the Courtyard of Wonders. Tenemos comida y bebida aquí en el Patio de las Maravillas, muy cerquita. Y nada, os esperamos para un networking con cervecita fresquita. Muchísimas gracias.
Muchas gracias.